Hello, and welcome to Invitation to Puzzles, where our goal here is to welcome you in to the wonderful world of puzzles, which come in a really wide variety of sorts. So we try and show them all, and I know it can be a little bit intimidating, but we try and help you get comfortable with everything that there is within the world. So today we have a puzzle by Bellsita called Triangular Assassin, and this is a Sudoku puzzle. So that means that I need to place the digits 1 through 9 in every row, every column, and every box of the grid exactly once each. So if this is a 9, I'm saying these cells can't be 9, for example. And I need to find a way to put all of 1 through 9 in these cells, for example. Now, you might have seen Sudoku before in various forms where usually there's a bunch of digits given to you in the grid. This is a different kind of Sudoku. This is called a Killer Sudoku puzzle. And in this puzzle, what we have is we're given the sum of some collections of digits. So, for example, this collection of digits sums to 39 is what we're saying. This collection of digits sums to 10. Now, there's one more rule that is important here, which is a slightly strange rule when you first learn it. But the other rule is that you can't repeat digits in a cage. So, for example, normally in Sudoku, if I made this a 9, it would be totally okay if this were also a 9. I am not allowed to do that in a Killer Sudoku. So if there's a cage here, which is what these are called, killer cages, then I can't repeat digits in it. So if this is a 7, again, that can't be a 7 because they're both in the same cage. All right, there's a link down in the description if you want to try the puzzle. I would encourage you to give it a go, but we're going to give it a go together. So if you get stuck, just come back and I'll be here to help you. All right, so how do we get started with a puzzle like this? A key thing to look for in one of these puzzles is to look for cages that can only be filled in one way. What do I mean by that? Well, for example, let's look at this 6 cage down here and think about what digits we have to put in it. And the answer is that we have to put the digits 1, 2, and 3 in it. Because that's sort of the minimum 3 digits I could possibly put in here would be 1 plus 2 plus 3, and that is 6. So if I try and put a 4 in here even, I'm already cooked. Because if I try and put a 4 in this cage anywhere, then I can't make this cage sum to 6, no matter how hard I try. Okay, so the digits that go in here are 1, 2, and 3. And so I can mark that in a few different ways. And so there are sort of 2 classical kinds of markings in Sudoku. There's the center markings and the corner markings. I'm going to use center markings here. And what it means when I center mark a cell is that this cell is from 1, 2, or 3. This cell is from 1, 2, or 3. And this cell is from 1, 2, or 3. However, here it's even actually better than that. Because not only are each of these cells from 1, 2, and 3, these 3 cells are 1, 2, and 3. I just don't know what order they go in, but I know that they're 1, 2, and 3. And so they're what I call a triple, or what everyone calls a triple, I should say, because I know that these 3 cells are these 3 digits. In particular, the rest of the cells in this row, they can't be 1, 2, or 3. If I try and put a 3 here, for example, I have again broken this 6 cage because now this 6 cage now has to have a number in it that's bigger than 3 because there aren't 3 numbers that I can put in it anymore if I put a 3 over here. Okay, so this digit, if I wanted to mark it, it can only be 4, 5, 6, 7, 8, or 9, but that's probably a little overkill. Okay, so we can continue to hunt and play with totals. And so the interesting totals, or some of the interesting totals, are just what you get if you generalize this idea. So we said 6 was interesting because it was 1 plus 2 plus 3. It was the minimum possible sum of 3 digits. Well, what's the minimum possible sum of 4 digits? Well, that'd be 1 plus 2 plus 3 plus 4. That's 10. And so you'll see that actually shows up here. That cage is a 4-cell 10 cage. And so at a minimum, it would be 1 plus 2 plus 3 plus 4. But that's also the most I could make it. So again, just like the 6 cage, I can't possibly even put so much as a 5 into this 10 cage. If I do, then it's already broken. Okay. If I were to add the digits from 1 through 5, that's 15. That's the minimum size of 5 cage cell cage. Sorry, that's the minimum sum a 5 cell cage can have. There aren't any of those in the puzzle, though. Okay. I do want to emphasize, by the way, how important the digits can't repeat in cages thing is, because if digits could repeat, then instead of having to be 1, 2, 3, 4, which is what I've claimed this thing has to be, I could do something like 2, 2, 1, 5. These numbers do sum to 10. But notice it's yelling at me. It's very unhappy with me for doing that because, again, I'm not allowed to repeat the 2. And so the only reason why this has to be exactly the digits 1, 2, 3, 4 is because I can't repeat any digits inside this cage. It's one of the rules of Killer Sudoku. Let's continue up the chain, though. So we tried 5 digits. What about 6 digits? If you sum 1 through 6, then you get 21, in fact. And then you might see this cage, which is a 6-cell cage. A 6-cell cage is always going to sum to a minimum of 1, 2, 3, 4, 5, 6. That is a minimum of 21. And that's also what this one sums to. So it has to be that. This whole minimum equals maximum thing shows up in a lot of places where you might look at math in Sudoku puzzles, especially. Okay. We can go one further. What if I add 7 digits together? Then I'd be adding 1, 2, 3, 4, 5, 6, and 7. And those add to 28, which, lo and behold, is up there. 1, 2, 3, 4, 5, 6, 7 fitting in here. Okay. Now, I should note the reason why this puzzle is called Triangular Assassin. Well, the assassin is a pun on the killer part, but the triangular is because these numbers that we've just talked about, 6, 10, 15, 21, 28, these are called the triangular numbers. They're just the minimum that you can fit in any particular cage of any particular size. So in a 2-cell cage, the minimum is 3, a 1 and a 2. And so 3, 6, 10, 15, 21, 27. You're going to see those numbers a lot in killer puzzles because those are, again, the minimums. Now, you don't have to memorize that. If you do these puzzles enough, you will sort of internalize it. But also, Sudoku Pad has a helpful feature that if you go through here and you click this advanced option, Killer Calculator on, then if you click on any cage, like this 5-cell 19 cage, for example, here, then over in the rules, which for you will probably be on the right, but for me is right here, there's this little bar where it will show you all of the ways that you can make 19. Now, there are an awful lot of ways to make 19, so that's probably not super exciting for you. But the cages that we just looked at, if you look at those, so for example, here's the 28 cage, you see there's only one way. And so the cages that you're looking for to start with are probably the cages where there's only one method to make them. Okay. There are actually 2 more cages in the grid that have only one way to make them. So I'll give you a second to sort of look for what they are yourself before I jump in and show you. Okay, but those cages are actually sort of the opposite of what we've been doing so far. So this 24 cage is one of them. Here, the problem is actually the exact opposite of the 6. The problem with the 6 was if we wiggled even a little bit from the minimum, it was too big. The 24 is if we wiggle even a little bit from the maximum, it's too small. So 7, 8, 9, exactly the 3 biggest digits that I could pick, those add to 24. So these digits need to be 7, 8, and 9. Likewise, the 30 is the other one. the maximum I can make 4 digits add to, provided they have to be different, which they do, remember, is 6, 7, 8, 9, which is 30. Like that. Okay, and so that gives us a lot of sort of starting spots to look at when it comes to trying to see what is going on in this puzzle. But I want to point out what the very first thing I said was, which was that this had to be 1, 2, 3, and so nothing else in this row could be 1, 2, 3. And so that's actually going to be quite useful, because if nothing else in this row can be 1, 2, 3, well, these can't be 1, 2, 3, so I can just take those out. But if you look closely, now these digits are 4, 5, and 6. And again, they're a triple of 4, 5, and 6, which means I can't put 4, 5, or 6 in these cells. If I did, I'd be repeating the 4, the 5, or the 6 within the cage. So therefore, these cells are 1, 2, 3, and these are the 4, 5, 6. Okay. Now, these are the 4, the 5, and the 6 for 2 different places at once. They're the 4, the 5, and the 6 for the cage. Actually, for 3 different places at once. They're the 4, 5, and 6 for the cage. These are also the 4, 5, and 6 for the row, which means that these digits are not 1, 2, 3, and they're not 4, 5, 6. So these 3 digits are identically 7, 8, and 9. But also for box 9, which is just what we call this box, is just you go like a phone pad, box 1, 2, 3, 4, 5, 6, 7, 8, and 9, if you're talking about them. This 4, 5, and 6, this is the 4, the 5, and the 6 for this box. And so in particular, I can't put a 6 here, because if I put a 6 here, for example, notice that obliterates my ability to put a 6 in one of these cells, and that doesn't work. So these aren't 6. And now, whichever way you want to look at it, where is the 6 going in the 30 cage, which definitely needs a 6? It's going here. Or if you want to think about it the other way to think about it would be, we said these digits are 7, 8, and 9. If these are 7, 8, and 9, this cell, well, it can't be 7, 8, or 9. It would break these 3 cells, so this has to be the only other thing it can be, which is 6. And so we get our first digit in the puzzle, namely this digit of 6. Okay. Now, anytime you sort of get a digit like that, you should ask yourself, is there something that digit I just deduced did? And often the answer, if a puzzle is well put together, is that it will do something for you. And it might not be clear what the thing is at first, but it should do something for you. And so in this instance, the thing I see about the 6 is the 6 looks over at this 14 cage. And now if you had clicked through all of these various cages, then you would have seen that the 14 cages have only 2 options. Namely, the 14 cages, the 2-cell 14 cages could only be 5, 9, or 6, 8. And the thing that this 6 does is it tells us which one this is. Namely, there's not a 6 in here, so this can't be 6 plus 8. This can only now be 5 plus 9. Okay. And here's where the Sudokuing intensifies. Because if you look at this pair is a 5 and a 9. That tells me these digits now, it looks back over, these can't be 9. Because the 9 in row 8, if you want to think about it this way, the 9 in row 8 is in this cage. So it can't also be over here. I've put 2 9s in row 8. So there's no 9 in here. But now we have a 7, 8 in these 2 cells. These are a 7 and an 8, and therefore that cell now can't be a 7 or an 8. It's a 9. Okay, and that looks up there as well. So that gives us a lot of sort of beginning places to look in this grid. Also, I lied before. I didn't notice this. but it just became apparent. I said there were only two other cages that were forced. This cage is also forced. This 39 cage, this 39 and 6, it has to be the biggest it can be, which is 4, 5, 6, 7, 8, 9. So these digits are 4, 5, 6, 7, 8, 9. Thank you to the wonderful Killer Calculator for helping. And I'm going to do a very similar thing to what we just did down here, which is to look at what this 789 does to this 39 cage. And if you're new to this, take a second and look at it and see what this 789 does to the 39 cage. Okay, namely, what the 789 does is to rule 7, 8, and 9 out of these cells. Because we know where the 7, 8, and 9 are in this row. They're over here, so they're not also here. Okay, and so much like the 21 cage, but kind of upside down, if you will, this 4, 5, 6 now is the 4, 5, and 6 for the 39 cage. So these aren't 4, 5, or 6. These are now 7, 8, and 9. And so we can sort of continue that same bouncing of now that 4, 5, 6, and 7, 8, 9 in row 1 tell me that these three cells can only be 1, 2, and 3. And now that 1, 2, and 3 tells me this digit has to be a 4. Because it can't be the fourth 1, 2, 3 for the box. Okay, so we've got no 4s over here, no 4s over here. In fact, actually, that 4, 5, 6, if you like, also took 4, 5, and 6 out of these cells as well. So those are not 4, 5, 6 either. Okay. So let's have a look at what else is going on now that we have all of that. A thing you might look at is you might look at what the remaining cells in this box can be. Because just like this row had a 4, 5, 6, and a 7, 8, 9, so it was left was a 1, 2, and 3, this box has a 1, 2, and 3, and a 7, 8, and 9, so what's left is a 4, 5, 6. Okay, and that one can't be a 4 because there's a 4 in the row already. Okay, and so if you look at this column now, you can actually repeat this process, because within this column, we've got our 1, 2, 3, and we've got our 4, 5, 6. So what's left is a 7, 8, 9. That's one of the 7, 8, 9s. These are the other two 7, 8, 9s, if you would like to think about it that way. So we end up with that 7, 8, 9 over there. Okay. So what about this cell? What is it? Okay. And this cell is what we call a naked single. And what that means is there's actually only one value that this cell can be. And so it can't be 1, 2, 3 because of the box. It can't be 5, it can't be 6, it can't be 7, 8, and it can't be 9. And if you just want to think of that, I skipped 4 because 4 is the only value it can be. It can't be 1, 2, 3, and 5, 6, 7, 8, and 9 are all in the row. So this digit is always a 4. Okay, and that's called a naked single. It's when a cell only has one value it can possibly be. And so in this case, that was a 4. And just because that was so useful, I'm going to go ahead and fill in for the rest of this row what's left. We've got the 4, the 5, the 6, the 7, the 8, and the 9. So the only things left are 1, 2, and 3. So these are from 1, 2, 3. Now, similarly, you can look at something like this column. And you can think about this in a couple different ways. There are several ways you can look at this column. One of them is what's called the hidden approach, which is sort of the opposite of the naked approach, if you will. This video is still getting demonetized, which is to ask the question, where is 9 in this column? Okay, and you might think of asking that question by looking at this giant collection of digits and noticing, hey, none of these can be 9, and that can't be 9 either, and this also can't be 9 because of this 9. And so, in fact, actually, that cell just has to be 9. The other way to look at it is you might say, okay, all of these digits are from 1, 2, 3, 4, 5, 6, 7. Note, this one can only be some of those. These can only be some of those. But these digits are all from 1 through 7. And so is that one. And that's 7 digits. So these 7 digits have to be from 1, 2, 3, 4, 5, 6, 7. So they just have to be 1, 2, 3, 4, 5, 6, 7. It's the fancier version of the these 3 digits have to be 1, 2, 3 trick that we did earlier. And so what does that mean? That means these digits are 8 and 9, the 2 digits that aren't 1 through 7. But this one can't be 9, so this is the one that's 9, and then that's the one that's 8. So you can take that as well. And now we know what these 2 digits are, because we know everything else that is in the box. So it's not 1, 2, 3, 4, 5. These digits are 6 and 7. Okay, now take a moment to check and scan the grid and see if you see how we know which of these is 6 and which of these is 7. It's good practice for what's happening in this puzzle. Okay, right, and so the thing to look at is these cells. And again, these cells are a 7, 8, 9 triple. So they're one of each, 7, 8, and 9. And so they look down at this cell, and so this cell can't be 7, or that would rule 7 out of these cells, which need to be 7, 8, and 9. So in fact, that's 6, and that's 7. Okay, and so now, if you look back up, now actually this has become a 5 by virtue of that. And this is no longer able to be 7. And actually, now something quite magical has happened, which is that if you look at row 2, now there's a triple in row 2. I'll give you a second to squint and look for it. And so if you identified these 3 cells, you're right. And yes, it takes a lot of practice to get used to spotting these. But in time, you'll get there. And so this 1, 2, and 3, those are, again, they have to be the digits exactly 1, 2, and 3. And so that makes this digit a 7, because it can't be a 1, 2, or a 3. And now this digit's not a 1, 2, 3, and it's not a 7. Those aren't 7. Those are 8 and 9, which now, remember, means that that's 7. Oops, I hit too many buttons. So now we've got that 1, 2, 3. Okay, that is no longer a 7. And so we have all of this set up. Now, you should pay attention when you see a cage like this 33 cage that has only 2 options. Because maybe the options share something in common. So for example, in this instance, those options share in common the 7, the 8, and the 9. So there's always a 7, 8, and 9 in this cage. Well, where are they? Well, they're not there because there's a 7, 8, and 9 looking at these cells. So if you want this as the hidden approach, I need to put a 7, 8, and 9 in this cage. They aren't there, so they need to go here. So these are a 7, 8, and 9. But actually, if you look at it, and maybe you saw this right away, I I know where the 7 goes, because the 7 actually, if you want to think about it this way, the 7 looks at every cell in this cage except for 1. So that cell actually is the 7. Okay. And so now you look back at this cage and now you say, okay, well, it was either a 3-6 and a 7-8-9 or a 4-5 and a 7-8-9. And now if you look at it, you go, oh, I know which one it is, because there's a 6 in the row. And so these need to be not 3 and 6, but 4 and 5. Okay, and so now for the row, these two are the last 1, 2, 3, because we've got 4, 5, 6, 7, 8, 9 taken care of. Okay. All seems to be going reasonably so far. This cell I see is a 1, 2, 3 by the box. Over here, if I look at it, I've got the 4, 5, 6, 7, 8, 9. I'm just missing a 1, 2, 3. Now, if I look at this column now, I've got my 1, 2, 3. I've got my 7, 8, 9. And I've got my 5. So this cell is a 4 or a 6. So we have that. This cell being a 4 or 6. Now, there are lots of ways that one can look at this, but I want to point out something that you might be inclined to ask once you do this for a bit. And it's probably not a question that you're immediately inclined to ask. But you might notice that this 4-6 is kind of interesting in this 28 cage, because I need to put this 4-6 in the 28 cage somewhere. And so you might ask if you know anything about where the 4 or the 6 go in this 28 cage. And again, that might be a leap at first, but when you know that this digit has to go somewhere, it's reasonable to ask if you know anything about it in this cage. And it turns out I don't know much about the 6, but I actually know a decent amount about the 4, which is that I actually know the 4 within this cage doesn't go in any of these cells. I can just look at the center marks if you want and see none of these things can be 4. So the only place I can put the 4 in this cage is in one of these cells. Okay. But if that's the case, that means that the 4 in this cage is definitely in box 4. So this digit can't be a 4. If this digit was a 4, then I would have ruled 4 out of the entirety of this cage. Okay. Alternatively, if you want to look at this a slightly different way, the other way is to ask, where is the 4 in this cage? It's definitely down here. That looks up at this cell and tells me that cell can't be a 4 either. So either way you do it, what you're going to get is that this cell has to be a 6. And that cell's a 6, and that cell's a 4. Owing to the way that has all worked out. And so now we have our 11 cage. And so it has a 6 in it. And so this is either going to be a 1 and a 4 or a 2 and a 3 in some order. Those are my options for what is allowed here. Okay. I want to look at this row because I've got almost everything sort of set up in this row. And the thing I notice in this row is that this digit is, well, it's not a 1, 2, 3. It's not a 4, 5, or 6. And it's not a 7. So this digit's only an 8 or a 9. If you like that sort of thing. Let's see. This row, we've got all the 1, 2, 3s. We've got some 4, 5, 6s, 1, 8, 9. Not sort of immediately useful. I should probably write down that I noticed that this cell had to be 2, 3, or 4 based on what went with the, whether this was a 1, 2, or a 3, basically. Okay. Do I know anything about this 19 cage that might be useful? I'm going to go with no, I don't think so. About this cage, I don't think I know anything about that either. Okay, what else do we have kicking around then? These are 1, 2, 3. If you look at the column, because we've got the 4, 5, 6, the 7, the 8, and the 9. So these are from 1, 2, 3 only. Let's see, that's 2 1, 2, 3s in the row at least. The 4, 5. Okay, what else can we do? We know there's a 7. Oh, that's it. Okay. Here's what I know about this 19 cage. Namely, what I know about this 19 cage is I know it has a 7 in it. And the way I know it has a 7 in it is that by Sudoku, if I look at where the 7 goes in box 2, it goes in one of these two. Okay, and you'll hear me every time I talk about Sudoku, you'll hear me re-emphasize the importance of using clear and consistent notation. And just about everyone who does this sort of communicatively, at least, uses the same notation. And so I mentioned before there's the center marks and the corner marks, and so far I've only used the center marks. This is a corner mark, and all that corner mark means is one of these digits is a 7. Okay, and so you'll notice this is actually a fairly useful interface. I can say, so I know there's a 7 in the cage. You click the 7, and then it shows you only the combinations that have a 7. Okay, so I know this sum to 19. I know it has a 7. But it's actually better than that because that actually is going to tell me where the 7 is in box 6. Okay, now take a moment and trace that through. Make sure you believe you understand where the 7 is in box 6. So by raw Sudoku, the 7 in box 6 isn't in any of these cells. By the fact that there's already a 7 in this cage, remember digits don't repeat in cages, so there's a 7 in this cage, that's not a 7. Also, this cage sums to 7, so it doesn't have a 7 in it. Okay, and therefore, what we get out of that is that this digit exactly is a 7. Okay, so we get our we find the 7 there. Okay. I admit that didn't do as much as I thought it was going to. It all looked so intentional. Okay, so in these cells, we have a 5, 6, we have a 7, and we have an 8, 9. Do I know anything about... okay, so I know the 7 actually is the largest digit in this cage. So actually, if I look at this box, I actually know that this digit that's gone with the 7, it's not a 1, 2, 3, 4, and so it can only be a 5, 6. So I can actually write in that these are 5, 6, 7. And so that digit in the box, it's the last 8, 9 for the box. So this digit here is an 8 or a 9 for sure. Okay, and so I've got my 4, 5, 6, 7 hanging around down here. Now, if you look at the killer calculator again, what you'll see is if I've got a 7 and a 5 or a 6, I don't get any more digits as high as 5 or 6. The only remaining digits that I have left are from 1, 2, 3, 4. So I can actually write in that these digits are from 1, 2, 3, 4. And they could be 1, 2, 3, or they could be 1, 2, 4. Either way, it gets me some more digits like that. Now, if you look at the cells I have highlighted, it will actually tell you whether the digits in the cage are 1, 2, 3 or 1, 2, 4. And that's because the digits I have highlighted in column 7, those are a 1, 2, 3, 4 quadruple, meaning that they have to be, in the final solved puzzle, a 1, a 2, a 3, and a 4. Now, that tells me a few things. Well, one of the things it tells me is that digit's not 4 and that digit's not 4, because we've already found the 4 in the column. But actually, you can see a little bit more, which is that this cell and this cell aren't the 4. One of these two is the 4. And so that means actually there is a 4 in this cage. Sorry, I didn't do the thing I wanted. There is a 4 in this cage, and so this cage is in fact 1, 2, 4, 5, 7. Okay, so there's no 3, and there's no 6. These are a 5, 7 pair right there. Okay, that 5, 7 pair looks over here and makes that a 6. Makes that a 5 and a 4. Makes that a 6 over there. And now that's going to start unraveling the ball of yarn as we work on this, because now we've got, as you can see, a whole bunch more things sort of clicking into place just based on that. Okay, this column needs a 9, an 8, and a 7 beyond that stuff that we already have. And I see what's going to give it to us, which is to ask where 6 goes in box 6. Okay, and so if we just look by Sudoku, I've got a 6 in both of these columns and a 6 in this row. Okay, and so this is a thing that is not so useful in classic Sudoku where you've just got numbers, but in Killer Sudoku can be very useful, is to notice I actually know the 6 goes in one of these two cells and they're both in this cage. Okay. Well, if one of them is a 6, the other one is a 1 because they add to 7. So these digits are in fact a 1, 6 pair. Okay, and that's going to do a lot of damage. And I think it's going to resolve basically the whole rest of the puzzle. Because now I can't put a 1 in these cells. Because there's already a 1 here. That's the 1 for box 6, so there's no more 1. So now these are a 2 and a 4. Well, that means this cell is not a 2. It's a 1. There's already a 2 in the cage. It's in one of those two cells. And so this cell now, it's not a 1. It's not a 2. It's a 3. So you can see how this unravels. That's going to be a 3. Okay, and so now that's a 2. That's a 1. That's a 2. Okay, and now that's a 3. Here. Like that 2-4 pair also looks up at this cell, making that a 1. Which has made that over there a 2-3. This is not a 1. That's not a 3. That's not a 3. Let's see. Okay, we know this cell is an 8 or a 9, actually. If you look at the column, again, it's not 1, 2, 3, 4, 5, or 6. So it's 7, 8, or 9, but it's not 7 either. It's an 8 or a 9. And the reason why I point that out is it tells me what this digit is, because this digit is now, again, a naked single. It's not 1, 2, 3, 4, 6, 7, 8, or 9. What digit did Zeta not say? Zeta didn't say a 5. And so that digit is a 5. Okay, and we also now have a 2, 3, 4 triple running across this row. So the only digits left in this row actually are an 8 and a 9. So that digit right there is an 8 or a 9. And 8 or 9 goes with 5 or 6 in this cell. But we're going to know which one it is if we notice this 8-9 pair. So this 8-9 pair here looks down at that cell, making that a 7. Okay, and that bounces back up, making that a 5 and that a 7, which bounces back down, making that a 6 and that now an 8, because 6 plus 8 is 14. And now if we just sort of fill in the digits that Sudoku Pad tells us to fill in, I think the whole puzzle will solve. 9, 8, 9, 8. Was I overly optimistic? Let's see. What am I missing now? Do, 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 do. Okay, I know these are a 4 and a 5. What are these two digits, I guess, is a good question. Let's see. I guess there's 4 cells in the grid I haven't pencil marked yet. I should probably pencil mark them. These are 5 and 9 is what they are. So that is the 5 and that's the 9. So that is not a 5. This is 1, 2, or 4 by the row. Those are the digits that are missing. But it's not 1 or 4. So this digit is a 2, which makes that a 1 and a 4. Makes that a 1 and a 2. Makes that a 3 and a 1. That is not a 4. That's not a 2. That's not a 4. Okay, and so now, actually, if you're sort of used to this, you might see that there's a 1, 2, 3 triple in the cage, or you might see that there's a 2, 3, 5 triple in the cage, or you might see that there's a 2, 3 pair in the cage, or a 2, 3 pair in this box. There's lots of options at this point. Let's go with the 2, 3 pair in the box, makes that a 5. The 2, 3 pair in the cage means that's the 1 for the cage, which means that this digit is a 2 or a 3. And now that finally means this digit is a 3, because I need these two digits to be 2, 3 now, in order to add to 5 to sort of fill out my 11 cage. And so this can't be a 4. If this is a 4, it would be too big. So that's a 3 and that's a 2. Okay, so that's going to sort out my 3 and 2. 4 and 2, 3 and 2, 1, 2, 3, 4. Okay, and that is a very beautiful killer puzzle by Bellsita. It is one of my favorite puzzles of this sort of practice with pencil marking genre, if you will. I really enjoy this. And so great job to Bellsita. Congratulations to you if you solved this. I hope you learned something. And I hope you'll come back for more sorts of puzzles in this Invitation to Puzzle series. As always, if there's a kind of puzzle that you're interested in learning more about, or you've never quite been able to get your head around, or that sort of thing, just let me know. I'd be happy to try and make some videos regarding that kind of puzzle. So I look forward to hearing from you all. I hope you enjoy these, and I'll see you soon. Bye for now.